low pressure system.
Right, so for the low pressure system, what is a bobbin? A bobbin. The small ball, like a, it looks like a ball bearing. Okay, this is some of these flow meters have rotometers. These things are called rotometers, and some have bobbins. Okay, just like a little ball going up and down. The advantage of a rotometer is that they spin as the gas flows through them. They've got a little what do you call it, fan or whatever at the bottom that makes it spin as the air goes through it. Okay, so just a visual, it just helps you visually to see that there's some movement there. Okay, while as a bobbin only goes up and down, you don't really see it spinning. Okay, so it's just an extra safeguard so you can visually see something is going through. Okay, because a bobbin can get stuck somewhere in the middle, and then you think, oh, it's going, but it's actually stuck. Okay, so that's why you also test that they go up and down like they should. Right, now once we had the low flow system, you close your flows again. Okay, so it was all the while on 8 liters per minute. Now you close it. Right, and what you want to do is you want to obstruct the patient side. Okay, so you'll see the circuit. There's basically two circuits or two entities to your circle system that you can use. There's the manual side. Okay, this side obviously connects to the patient. Okay, and with your reservoir bag, you can manually ventilate the patient. All right. Now to manually ventilate the patient, you have to be able to generate the pressure in the system. Right. To generate the pressure, you've got an APL valve. Okay, that you have to close. If the APL valve is completely open, then you can't generate any pressure. Okay, then everything just escapes at the valve. Right. If you close it completely, then in most systems you can generate the pressure of about between 70 and 80 centimeters of water. Okay. Just open the oxygen while we do that thing. Right, I said you close there. Okay, this machine has also got a huge leak, so just ignore it. It's supposed to be like that. Alright, so you close the APL valve. The APL stands for alternate pressure lever. Okay, it's the alter, but we still use it as the APL valve. So you close your fresh gas flows or your flow meter, you close your APL valve completely, and then you use your oxygen flush to fill your reservoir bag, which is then not working.
Yay.
Alright, so you use your oxygen flush to then fill your oxygen bag, okay, while you're closing the patient side. Now, what you're also testing is that your oxygen flush is working properly. Right, what the oxygen flush does, it gives high flow oxygen, so it's usually above 15 liters per minute, okay, so between 15 to 20 liters per minute, depending on the machine, of pure oxygen that bypasses everything, okay, and just delivers oxygen to the patient. Okay, and that's for any emergency situation. If you immediately need 100% oxygen, then you would use your oxygen flush to bypass everything. Then you get very high flows of oxygen from the oxygen flush. Right, so if you test it, you want to obstruct the patient side, and you want to see that this bag fills very quickly. Okay, it shouldn't be slowly, it should be very quick. Right. You want to fill the bag to a pressure of 30 centimeters of water. Right. Now, in theory, if there's no leak, then the pressure should stay at 30 centimeters of water. Right. If there's a leak, then obviously the pressure is going to start falling. Right, so what you do is you fill the bag to 30 centimeters of water and you see if it stays there. If it doesn't stay there, then you open your oxygen flow to see at what point it stays there. Okay, now it's stable. Right, so I know my leak is 4 liters per minute. Right, you follow that. Alright. Everything is closed now, man, and all the flows are off. Okay, I use my oxygen flush to take my system to a pressure of 30 centimeters of water. Okay, if there's no leak, then it should stay there all the time. Okay, because there's nothing leaking. But obviously, if something's leaking, then the pressure is going to start dropping. Okay, so I try to compensate for that leak by opening my fresh gas flow. Okay, and at that flow where the pressure stays constant, I know that's the amount of air or amount of gas that's leaking. Right, and that's about, and I read that off my rotimeter, and it's about 3-4 liters per minute. Right. Now to efficiently give anesthetics, or low flow anesthetics, we obviously don't want the leak to be more than a liter per minute. Okay. So all elective surgery we probably delay until we've found out where the leak is. Obviously, if it's an emergency and it's a stab heart, something that we have to continue, then we'll continue, but we'll all the time then have to compensate for that leak. Right. Right, and then also you just want to test that you can generate some more pressure in the system if you want to. Okay. So if you press the bag, you should be able to generate pressure. You shouldn't just Right, so, and now we know we can manually ventilate the patient. Okay, the other part of the system is if you want to use the ventilator to ventilate the patient. Alright, now to do that,